Good day everyone! Today we will talk about something really important in the world of electronics, the problem solving and critical thinking. These skills are important for fixing and improving circuits that help us make things work better. This project is entitled Circuit Mastery, Problem Solving and Critical Thinking in Electronics. In this video, we will explore three main ideas. First, how to identify problems in circuits. Second, the techniques we can use to troubleshoot them. And third, how to evaluate our solution to make sure everything works perfectly.
Before we dive into the topic, let me introduce to you our amazing team who worked together on this project. Maxin Mercedes, Julo, and Julo Magbanua. They focus on research and identifying common problems in circuits. Christmah Dimalaluan. She demonstrated troubleshooting techniques and solution in action. Kirsten Panahon. She handled the evaluation process, making sure the solution were effective. And I am Cyndrix, Alleen, and Sermona. I work on presenting the concept and tying everything together for this video.
Together, we will combine our skills to bring you this informative and exciting project. Now, without further ado, let's get started. Here, in the first part of our video, Problem-Solving Strategies in Electronics, we will demonstrate how to design and troubleshoot a simple circuit by walking you through a common problem scenario. Imagine we have an LED circuit that's not lighting up. Let's solve this step by step.
First, we identify the problem. In this case, the LED light isn't lighting up. This tells us something in the circuit isn't working as expected. Let's figure out what's wrong.
Next, we analyze the circuit. Here's the schematic of our setup. We have an LED, a resistor, and a power supply. Let's double check the connection on the breadboard to ensure everything matches the diagram.
Now, we will test the components using a charger as an alternative since we have no multimeter. Let's start with the power supply to make sure it's delivering voltage. If the LED doesn't pass the test, we know that it is the problem. The LED lights up, so the power supply is fine.
We also tested the LED with the resistor. All the LEDs was tested using our improvised alternative multimeter.
In our case, the connection is faulty, so we will tighten it. Now, let's reconnect everything and test the circuit again. And there we go! The LED is working perfectly now. By following these steps, we've successfully identified and solved the problem.
First, let's ask some questions. Why are we using this specific resistor? By challenging these choices, we can find ways to improve the circuit.
By challenging these assumptions, we open ourselves up to new possibilities, which can lead to better performance or efficiency.
Let's test the circuit with changes. What happens if we change the resistor value? For example, reducing the resistor value might speed up the response time, but it could also increase power use.
Here, I successfully removed one resistor. Then I start to reconnect the resistor to the wires. Struggle in reconnecting wires is real, haha. Finally, I'm done. Patience is very important in electronics.
Now, let's compare the original and modified circuits side by side. The modified version has a faster response time. However, it uses more power, which may not be ideal for battery-powered projects.
By testing and comparing, we learn the pros and cons of each choice and make smarter decisions.
After testing different components and configurations, we need to assess which version of the circuit is most effective. Does the modifying design really address the issues we identified earlier, like improving the response time or reducing power consumption?
We also need to consider how easy it is to build and maintain. A complicated design might cause problems later.
We need to balance performance, simplicity, and cost to choose the best design.
We also simplify the connections, making the circuit easier to build and more reliable.
In the end, our design works better, is more efficient, and is easier to assemble. Here's a quick summary. We questions our component choices. We tested different solutions step by step. We work as a team to make the best decision.
I learned to question our choices because better solutions aren't always obvious.
Experimenting with small changes showed me how even tiny adjustments can improve performance.
Teamwork helped us solve problems faster. Everyone's ideas mattered.
Critical thinking and teamwork are key in electronics. They help us find creative solutions and overcome challenges.
Thank you for watching our video. We hope you gained some valuable insights into troubleshooting, design optimization, and the importance of teamwork in electronics projects.